Okay. It's a branch of AI that focuses on enabling computers to understand, interpret, and generate human language in a way that is useful. Wow, that's very deep. That's actually true. It's spot on. I don't know anything about it, but of course, yeah, that's fine. I mean, I'm just hoping that given that you saw the course on um the outline, you might have been curious to at least check what it is or something. Anyone else? Let me get one more response. Anyone else? Okay. Um, okay. Natural language processing is the technology behind how computers interact with human languages like English, Tree, or French in a way that is meaningful and useful. Okay, that's good. And then getting computers to understand human language or speech. Mhm. Okay, I think we are all on a very similar level of understanding of NLP, and that's good enough. So today we are just going to go into most of the theory. Okay, I want to by the end of this, um, I want to see that you have understood what natural language processing is. So you should be able to define it and explain how it helps or it enables computers to work with human language. Okay. And then that you would understand, that you'd understand why natural language is challenging for computers. Okay. You recognize some key NLP applications like chatbots, translation, sentiment analysis, and search engines. Okay. That you'll be able to differentiate between symbolic, statistical, and neural NLP. Okay. And then hopefully that you'll be able to run your very first Hugging Face model. Okay. If at any point I'm going too fast or you don't catch something I'm saying, feel free to stop me and I'll go back. All right. Because this is the introduction and the foundation. So if you don't understand it, everything else is going to be very, very strange to you. Okay. So let's start. Um, what is in the name natural language processing? So before we even start talking about what exactly it is, I want to break down the words composing this term and make sure that you understand what it means. So natural language processing comprises of natural language and then processing. So natural language is basically the human language that we speak, okay, whether it's your English, your Tree, your French, okay. And you know that natural language or human language has a lot of complexities in it, right? So we have ambiguity, we have context, right? There's culture, slang, grammar. Um, Human language is very unstructured. Okay. So I'll give you the example of English, of tree, and of crawl. Okay. And then we have, I think crawl is like pigeon. Ghanaians and Nigerians might be familiar with pigeon. And then what is processing? Processing is just it involves computation and algorithms, structured steps, okay, or rule based or statistical processes. Okay, and then it also involves systematic analysis and transformation. So NLP is a field of AI that enables computers to understand and interpret and generate human or natural language. Okay. Now let's take a closer look at what natural language is. Okay. And if a language is not natural, what is it? Okay. So the difference between natural and computer language. So natural language is the medium of verbal and written communication among human beings. Okay. The peculiarities of natural language involve it is something that evolves naturally over time. Okay. An example, in the olden days, if someone says cool, it would just mean talking about the temperature. But over time, the meaning of cool or the context in which it's used evolves based on the culture, etc. So now, when you say cool, it can mean awesome based on the context in which it's being used, right? Another thing about natural language is that it is inherently ambiguous and subject to the context in which you are talking about, right? So, if, for example, you say, I saw her duck, right? I think in American English, duck means like to kind of to dodge something, to like bend down to not dodge something, right? So if you say, I saw her duck, um, the actual or inherent meaning of this statement is based on the context. So it could either mean you saw the person's animal, a duck, or you saw the person duck, as in perform the action of ducking, right? The next thing is that natural language is shaped by culture and context. Okay, so an example is um, how far in the Ghanaian context, or I think even in Nigerian context, means how are you, right? But then perhaps in another context, if you say how far, person will be thinking about the distance, right? So words don't have an absolute meaning, but their meaning is subject to the culture and the context. And then another thing about natural language is that it is rich in nuance and emotion. Okay, so someone can say great job, okay, and it doesn't necessarily mean you did a great job, right? It could be sarcastic. So it just goes to um, say what I said before, that words don't have an absolute meaning, but it depends on things like the emotion behind what is being said. Okay, and then it is flexible and adaptive. So new words are coming up every day. You hear of words like doomsaw. I think selfie. Selfie is something that came up. I mean, it's not that recent, but it's not been there. I'm like when I was younger, there was no word like selfie. Something that has come up based on recent trends and Googling. Right. So that's the thing about natural language. It's easily evolves and new words are easily created based on maybe current trends or situations that are going on. Okay, and then we know some examples of natural language. I already mentioned before. We have English, Tree, and then French. Now, let's look at the flip side. We have computer language. All of us here, I think we've all looked at Python before because it's all class of 2025, so 2024. So at least you all know Python. You're all familiar with computer language. If there's anything you know about computer language, is that it's a set of precise rules and symbols, okay, that allow human beings to give step-by-step instructions to computers on how to perform tasks, right? So if you run a code and you are getting an error, it's because what you are not following a particular rule or symbol or a particular expected way of writing, okay, that a computer understands. So on the flip side of natural language, we have computer language, which is more formally structured and designed. Okay. So for example, in Python, you require exact indentation. Okay. It is not ambiguous. It's always if you write x equals 5, it has one and only one meaning. It means that what the value assigned to x is now 5. Okay. Another thing is that it is logical and rule based. So um when you are, let's say, writing rules or writing some code, it is all based on logic and rules, basically. And the next thing is that it is machine interpretable, and then it's purpose built for computation. So there's a purpose for whatever languages that you are working with. So you see that the two languages that we are comparing here, they are fundamentally different in the way that they are. Right? Natural language is more nuanced, more flexible, and computer language is more rigid. So this is just a little deeper dive into what exactly computer language involves. So when we talk about computer language, I'm sure that you've already come across the fact that computers understand things in zeros and ones, right? So this is what we call the machine language. Okay. And then low-level languages are the ones like C, Fortran, there's MoveAx, etc., which um, they have there's some level of English or some level of understandability to these languages, right? They are not as um, confusing as machine languages, right? But then they are also not very easy for a person to understand. Okay, and it takes a lot of time, practice, and experience to be able to work with them. And then we have high level languages like Python, Java, C++, which are they are still considered computer language, right? But then they are more humanly friendly, okay, and more abstracted from hardware. So when we talk about processing in natural language processing, we are basically looking at being able to um, let's say allow the computer to understand natural language using high level languages. Okay, so we are bridging the gap between how computer understands the computer language and natural language, but we are doing it at the layer of high level languages. Okay, I hope we are all okay up to this point. Any questions so far? Okay, all right. uh all right, so let's move on. So when we talk about processing in natural language processing, what does it involve? So this is a very surface overview of what processing involves in NLP, but we'll go more in depth as we move on. So when we talk about processing in NLP, we're basically looking at giving the computer an input of some kind of expression of human language, whether it's in text or it's in speech, um, whether it's in posts or documents or conversations or reviews. Okay, so we talk about giving the computer or the system human language in some form, and then the system being able to derive some level of understanding or meaning from this input. Okay, and then performing a task or producing an output based on whatever processing it is that you give. Okay, so what are some of the possible outputs of an NLP system? We can have a sentiment analysis. So sentiment analysis basically means identifying the sentiment of a text. Sentiment in the sense of whether the text is portraying a positive sentiment, a negative sentiment, or a neutral sentiment. Then language translation, which means that your NLP system can take in some text and then produce the text in a different language. Okay, and then we have text summarization. So you can take in a large corpus of text and provide a summarized form of that text, keeping the semantic meaning intact. Or you can take in an input as a question, okay, and produce an output. So an example of such a system will be ChatGPT, which can take in an input and produce an input of a question and produce an output of an answer. Okay, we have chatbot responses and we have content classification. So we'll look more in depth in this over the period of this course. Okay, so NLP is a subfield of artificial intelligence. Okay, as we all know, artificial intelligence is a field where, or let's say a field where people are just trying to give the computer the ability to do what human beings can do. So the subfields include machine learning, computer vision, NLP. You can think of machine learning as giving the computer the ability to learn in the way human beings learn, which is what? By experience. Okay. And then we can look at computer vision as giving the computer the ability to see and interpret what it sees in the way that human beings do. Okay. So NLP will then be giving the computer what? The ability to understand and communicate in the way human beings do, or using human or natural language. But this is not a trivial problem, okay? Or it's not a trivial field. And so I just want to explain to you, or let you see why NLP is um, particularly challenging for computers. So what's the core problem? The core problem is that most computing tasks work with predictable and structured data. Okay, for example, if you're looking at a mathematics task, giving a computer a mathematics task to do, if you say it should add 2 and 2, 2 plus 2 will always be 4. Of course, based on the level you are or the environment in which you are working, right? Let's say we are doing modulo, we are not doing modulo, we are just doing normal addition. 2 plus 2 always give you 4, right? So when we talk about image recognition, the photo of a cat will always have some consistent visual features, all right? And then when we look at database queries, data always follows some particular fixed formats. Okay. The thing about NLP is that it is supposed to be handling messy, creative, and the constantly evolving nature of human language, where the same word can mean completely different things depending on the context, the culture, and the intent. Right? For example, the example I mentioned before, where it says "great job," the same "great job" can mean a different thing based on the context, whether the person is talking sarcastically, whether the person is genuinely congratulating you or something like that. There are so many different nuances to the way that human language is, and that's what makes NLP particularly difficult for computers. Okay, so this is the example I gave before. I saw her dark. So for a human being, they will use intuition, context, and experience to understand the meaning of um, a given statement. And even for human beings, people don't naturally, they're not naturally born with the ability to understand or determine whether something is sarcastic or not. It's something that it develops over experience communicating with people. You develop that ability, right? And so computers can only see patterns in data, okay, and they need explicit rules or massive examples to learn. So if you want a computer to be able to understand um, communication or language in the way human beings do, then it needs to have a whole lot of data to that effect. It is going to be very hard to do it only with um, rules, like the way the computer will normally learn, right? And what are the main difficulties that are contributing to this? First of all, there's ambiguity, right? In that the same sentence can have multiple valid interpretations. Okay. And then it's also context dependent, right? So it means that um, the meaning of a particular text can change based on the situation at hand, the person who is speaking, or the context surrounding the conversation. And then there's informality or slang. So real language actually doesn't always follow grammar rules. Okay, and there's a constant evolution of how people express certain ideas and concepts. And then there's also cultural nuance. So the language is also affected by cultural knowledge and the regional differences, um, where whatever language is being spoken. Okay. So when we look at um, language, okay, language has layers, right? We can look at language in the form of the syntax, the way the words are arranged. And then the higher layer is semantics, what the words actually mean. And then the highest is pragmatics, what the communicator meant by the words that they said. And so I've represented this as a pyramid, showing how easy or how hard it is for the computer to be able to understand and interpret such things. So when you talk about human language, when we look at the syntax, how words are arranged, the computer would have an easier time being able to understand and interpret based on the syntax. And then when it comes to the semantics and then the pragmatics, it is more nuanced or harder for the computer to understand those things. Okay, so this is still looking at the why NLP is a difficult problem, or why NLP is not a simple field. Okay. So another example here is this comment here. Oh, great, another meaning, another meeting. Sorry. So when you make this comment, a person might be able to detect that this is sarcasm, right, and that the speaker is likely speaking from a place of frustration based on the tone and the context. Okay, but then when the computer takes in such a text and they see the word great, okay, great is a positive word. It is not as easy for, or it's not really, yeah, it's not a trivial thing for a computer to be able to identify that this is a sarcastic comment, right? And even human beings use years of experience communicating with others to be able to read between such lines. So if you said this maybe to a 5-year-old, they might think that it's a positive statement, right? So it's something that develops on experience communicating. And so common traps that a computer might have when it comes to interpreting human language is um, inability to recognize sarcasm, irony, and metaphors, because these are more complex forms of communication in the human language. Okay. Now let's go to the importance of NLP. Why is NLP important? So the first reason that we have here is NLP allows us or allows human beings to communicate better with computers. Okay, so um, it allows human beings to interact with computers in their natural language, which makes technology more accessible and user friendly. For example, now we have voice assistants like Siri, Alexa, Google Assistants, okay, which all rely on NLP to understand and respond to user queries. Okay. The next importance of NLP is for information extraction and analysis. Okay. So NLP becomes important when you want to extract valuable information from large volumes of unstructured data. Okay, such as social media posts, emails, and news articles. So an example is so of course you know that you can use normal code to just scrape this information or this data from whatever sources that you want. But then when it comes to actually making meaning out of them, NLP is um, becomes useful in being able to actually extract whatever information it is from the data that you have collected. Okay, so for example, businesses use NLP to gauge public sentiments about products or services by analyzing the customers' reviews and social media comments on those products or services. The third point we have is automation and efficiency. So NLP is the engine behind chatbots and virtual assistants, okay, which provide instant responses to customer queries and thereby help to improve service efficiency. Okay, so for example, NLP can be used for automating of processing legal documents and contracts and other text-heavy tasks. That's reducing manual labor in this fields. Okay, and then of course these are not the only importance, but these are just a select. The final one we have here is language translation. So thanks to NLP, now language barriers have been broken down to an extent. Most of or let's say a good number of languages across the world, one can translate um, between different languages, okay, and thus get information to people who speak different languages and information from them as well. Okay. So let's look at the brief history of NLP. Okay, before I continue, are we all on the same page? Am I moving too fast? Do you understand where we are so far?
Yeah, we are okay.
All right. So let's look at a brief history of NLP. Okay. So we'll start from the 1950s, the Turing test. So Alan Turing proposed the imitation game. If a machine can engage in a conversation which is indistinguishable from a human, then it can be considered intelligence. So this was a test that Alan Turing brought, and I think it was part of the rules for robots, right? To just to set some kind of benchmark for um, what level of progress or advancements in computing can we get to, where we can say that um, a computer or a machine has become intelligent. And one of the things he said was that if the machine is able to engage in conversation, which is indistinguishable from a human, then we can consider it intelligent. That was all the way in the 1950s. And now it is possible through the use of large language models like ChatGPT, right? But that's just to show you how far the idea has been from back in the 1950s. Then we have in between the 1960s and the 1980s the the symbolic AI era. So in this time, there were handcrafted rules and grammar systems. Researchers built systems using explicit linguistic rules and knowledge bases. Okay, so the first chatbot was Eliza in 1966, and it was basically using pattern matching. Okay, so the next significant point in NLP was in the 1990s, which was the statistical revolution. So in this time, there was a shift from the rules, okay, to statistical models. So we now started training machine learning algorithms on large text corpora, and this was replacing the handcrafted rules. An example is the IBM's statistical machine translation, which outperformed rule-based systems. Okay. Then in 2018, then from 2018 was the newer revolution. So that's where transformers, generative pre-trained um, transformers, BERT models revolutionized NLP. So these are all deep learning models, and they were able to help achieve human level performance on many language tasks. So this was where the Turing baseline for human or machine intelligence was now realized. Okay, with the creation of GPT-3 and ChatGPT, as well as the BERT model. And then now in 2025, we have multimodal and multilingual um, evolution. So we have large language models that understand text, images, audio, and video. Okay, and AI assistants that work across different languages and cultures. So example is the GPT-4, the different versions of GPT-4, 4.0, 4.5, etc. And even now, GPT-5. And then we have Gemini and the Claude, etc., etc. And these are models that are not only they are not just restricted to being able to communicate and receive human language, but they are able to also work with other types of data. When we say multimodal means different types of input, not just maybe speech or just text. It can also take in images, audio, and video, right? So these models are now able to interact with several modes of information or of data, and um, handle them in a way that humans would. Okay, so that's just a brief history on NLP. And now I want us to do a little test, okay, of some AI. So we can pick, I mean, I'm sure you all probably have a smartphone or even on your computers. You can pick an AI, whether it's Google Assistant or even ChatGPT or any other large language model. Okay. Then I want you to try and give it an audio message. Okay, but it should not just be any audio message. It should have some slang, some kind of cultural thing. For example, hey Siri, how far? Right? Something that is understandable as humans, but a computer might not understand. And then let's observe what the system is able to do with that information. Okay. So I want you all to try it and then um leave your what you got or what you saw in the chat here so that we discuss it briefly for about 5 minutes. If you cannot use any AI system yourself, I would use mine. So I have my phone here. I would open Google Assistant and then you can speak. You can say something and then we would just discuss how far this kind of system has gotten in understanding human language. Do you all understand what I'm saying?
Yes, please.
Okay. So words can work while limited. Okay. So your phone is where you're using to. Okay, if that's the case, then um you can do a mine. So I'm going to turn on okay. I'm going to turn on my Google Assistant and then Richard, if you want to say something, you can actually unmute yourself and just say it. And Google Assistant here will hear you. So it's on now. Who's ready to speak? Oh, it's got to be.
So do we talk now or
Yes,
is
we talk now.
oh okay.
Okay, are you ready?
Wagwan.
Yes. Okay, say it again.
Wagwan.
All right.
Please, is that one working?
It has cut it, so it's now thinking. I don't know if you can see the screen. Can you see what is on the screen?
No.
No?
Yeah.
Oh, it's gone up. Okay, so you didn't understand what you said, so it's asked me to say it again.
Ah.
So I didn't even catch anything. Priscilla wrote something here. Okay, if we are going literal, how far could be distance in meters, miles, or emotionally speaking, somewhere between just started and almost there. Okay, Priscilla, where did you get this output from? Is there anyone else who has tried something? ChatGPT, okay. Okay. So Tunde said he asked how you day. So where did you ask the how you day? Was it on ChatGPT? Because Meta, okay. Okay. So Meta has gone that far. they can understand how you do. That's amazing. And then Richard, all good on my side, just here to grab something. Whatever else you need, how about you? Hey, okay. So this one, Richard, this one is what? Is it ChatGPT? Okay. Okay. And then Priscilla said, when he said Wagwan, it said Wagwan, blessings and vibes, my friend. Mm, everything crisp. Hey, then uh so Priscilla, this one is also ChatGPT. Okay. Augustine, it's also okay. Augustina said she asked Siri how far, and then Siri gave her a Google map. Siri has not advanced. That's not advanced. Okay. And then Scholastica said, "I did here. Was it how far or which one?"
Yes, how far?
You just they reach the state where you're like, hey, okay. This one is giving you even memories from previous chats or perhaps the same chat. But since I know it's compare, hey, wow. Oh, that's interesting. Has anyone tried? Let's try the Siri. My phone is acting sus lately. Uh, yeah. So I want to see if you understand the meaning of sus, because sus is such a modern slang. Or you can ask ChatGPT as well. Has anyone tried it yet? Someone should try the my phone is acting sus. Hey. Okay, Richard has tried it. He said, hey Charlie, when phone starts do sus like that, it's either battery, storage, apps, updates. Okay. That's ChatGPT, right? Yeah. I mean, so that's just how far NLP has progressed. Um, it's able to understand very context, culture specific things. Okay. Priscilla also said, okay, seems glitchy and so creepy and funny. What kind of stuff are we dealing with? Nice. See guys, that's amazing. A good job testing AI. So we see that some of the models were less less able or were not as good in interpreting some of the context or culture specific language. Like I think was Meta good? Meta. Meta was good. Meta was good. Was there any that was bad? I think we all used very advanced models. Okay, Siri was not that good in identifying what how far meant. Yeah. So some of the models we see that they are not as advanced than as others are. Okay. Okay. So that was a nice interlude. Let's continue. What exactly is NLP? Okay. Are we all on the same page? What is NLP? So NLP is a branch of artificial intelligence that enables computers to understand, interpret, and generate human language in a valuable way. So when we say understand, what do we mean? Extract meaning from human text and speech. Okay. Then when we say interpret, we mean analyze context, intent, and relationships. And then we talk about generate, talk about creating human-like text and responses. All right. What are some common NLP tasks? There are so many NLP tasks. A couple of them include classification. So being able to categorize some text into some predefined groups or labels. So whether it is for a given email, being able to classify whether it is spam or not spam. This is an NLP task. Or whether it is given a review, being able to identify whether it's a positive or a negative review. That's also an NLP task. And then we have translation, right? Converting text from one language to another while still preserving the meaning of whatever the text is. That's also an NLP task. And then we have summarization. So creating concise summaries of longer text while keeping key information. For example, condensing a 10-page report into a one-paragraph summary or a long article into key bullet points. This is also an NLP task. Sorry. Then we have named entity recognition. Okay, so identifying classes of people, places, organizations, etc., or other entities in a text. Okay, for example, Apple released the iPhone. So being able to identify which one is a company, which one is a product. Okay, that's named entity recognition. And that's also an NLP task. What are some other NLP tasks, You can type them in the chat. Is there any other NLP task that which is not here? I mean, there's one that I'm expecting everybody to probably think, which is not here. You can you can speak or you can type in the chat. Text generation, yeah. Text generation. That's ChatGPT, right? Any other? Any other? There's one that usually happens on your phone when you're typing something and then it automatically changes it into another thing. What's it called? Autocorrect, yeah. So these are just a couple of NLP tasks that we can consider. So let's look at some applications of NLP in industry. Okay, so NLP is all around us, especially now more than ever, I think. So we have in the healthcare industry, NLP is useful for extracting insights from medical records, research, clinical documentation to improve patient care and to accelerate discovery. Okay, so for example, when it comes to clinical notes analysis, NLP is helpful for extracting symptoms, diagnosis, and treatments from doctor's notes. Okay, and then for drug discovery, NLP can be useful for analyzing scientific literature to identify potential drug interactions. Okay, in medical research, for processing thousands of research papers to identify trends, and then in medical chatbots to provide initial symptom assessments and health guidance. Okay, and then we can look at in the finance industry. So NLP is useful for analyzing market sentiments, automating trading decisions, and detecting fraud through text and speech analysis. Okay, so we have market sentiment analysis, fraud detection, earnings call analysis, customer service. Okay, and then in education, automated essay grading, intelligent tutoring, content summarization, plagiarism detection, right? And then in everyday life, for things like email spam filtering, autocorrect and prediction, voice assistance, real-time translation, um, and so on. This is just a select few. There are so many other applications of NLP in industry. I'm sure that if I ask you to list, you'll be able to get some, but because of time, perhaps. Wow, an hour already. Okay, so what's the general NLP pipeline flow? So of course, when it comes to um, the flow of text data through an NLP system, it mainly depends on the kind of task that you are trying to perform. When I say kind of task, I mean whether it's a summarization task, whether it's a fill in the blanks, a translation task, a text generation task, etc. That would determine the specifics of the flow. But in general, an NLP pipeline flow follows this process. So we have the raw text. For example, I love this movie. Okay. And then it goes to pre-processing. So pre-processing will involve cleaning the text, tokenizing it, and normalizing it. Cleaning the text is usually to remove any strange characters in the text. Okay. And then we can also talk about lemmatization, which is reducing the words into a basic form. Let me give an example. The teacher was teaching the students. Okay. So you realize that the word teacher and teaching come from a common root word, which is teach, right? So one of the processes of cleaning is um, basically, so to lemmatize is to kind of find all those words that come from a common root word and then identify what that root word is and let that root word stand in for the several variations of that particular word in the text. So that's just a couple of the things that constitutes cleaning, and we'll meet it later on as we go. Tokenizing is basically converting it into numbers or numerical form because the computer is not going to understand the text as it is, right? It needs to convert it into some numbers. And normalization is just converting it into, you know what normalizing is, right? Bringing it into a particular range of it. Then we have feature extraction, okay, and then we do model processing, and then the output comes out. So we'll later on in the class we'll look at some Hugging Face pipelines. Okay, for example, we'll look at sentiment analysis. And with the sentiment analysis, you will see that we just have a single function. We give it a text input and then we get the output. But behind the scenes, this process goes, this is a process that the text is going through. Okay, but we'll not look at that today. We'll only look at the surface process or the surface, what happens on the surface in code today. So let's go on to look at 3 approaches to NLP. It's almost 12. When it's 12, we'll take a 10-minute break and then we'll come back. So 3 approaches to NLP. We have the symbolic, the statistical, and the neural network methods or approaches. Okay. So the symbolic approach to NLP was developed and used between the 1960s. Let me say developed between the 1960s and the 1980s. Okay, and it basically involves some handcrafted rules and expert knowledge systems. Okay, so linguists and programmers explicitly coded grammar rules and language patterns. Okay, and so some key features of symbolic NLP are rule-based systems, expert knowledge encoding, these kind of systems are interpretable and transparent, okay, and they're usually precise for very narrow domains. So we're looking at the legal domain, the medical domain, etc. And then they are also brittle with exceptions, which means that whenever such a system comes across something which is not, um, let's say, it's not considered in its rule base, it breaks. That's what I mean by brittle. It doesn't. It's not very what's it, robust. Okay, and then we in the 1990s we progressed to let's say a more sophisticated way of doing NLP, which is the statistical NLP. So in this one, we basically use machine learning to learn from large text corpora. So just very, very large pieces of text from all over the internet. Okay. Or different sources of data. Then the statistical models basically learn patterns from the data. And so in this case, it's not human beings, it's not the programmer and the linguist typing down rules of subject verb agreement, sorry, um, predicates, clauses, and things like that. It's no more that. Now we're just giving the system several data and then allowing it to identify and learn the rules on its own. Okay, so the key features of statistical NLP is it was basically data-driven learning, okay, as opposed to the rule-based systems. Okay, and then we were using probabilistic models. Okay, so let's say when it comes to something like maybe a sentiment analysis issue or sentiment analysis problem, um, when a text is given to your statistical NLP system, then it will tell you that okay, with a confidence of 80%, this is a positive text, or with a confidence of 40%, this is a negative text. Right. So it does it based on probabilities. Okay. And then it handles uncertainties. There's manual feature engineering, and then it was relatively faster than the symbolic NLP was. Okay. And then in our current day, we are looking at neural NLP, which is basically involving deep learning with neural networks, okay, to automatically learn representations. So it's basically end learning from raw text. So the key features we have end-to-end learning, automatic feature learning, state-of-the-art performance, which means that these are the best performing NLP systems yet. And then it requires massive amount of data to train. And then they are much less interpretable. So, of course, with the improvement of performance of these models, that you can see that there's also a reduction in the interpretability. Interpretability means, or interpretability basically has to do with how easy it is for a person to understand the way in which the system made its decisions. Okay, so whereas for the symbolic NLP, these are rule-based systems. Not only do you understand how it did its decisions, but you're the one that wrote it. So it's work based on what you told it to do. With the data-driven learning, it is learning it on its it is learning the rules on its own, right? And so you can use, I mean, there are some methods you can use to easily identify um what are the most important things it was considering when making the decision, right? But when it comes to neural NLP, this is significantly harder to do. Okay, and that's why you have less interpretable there. So these are just the approaches to NLP. There's no there's no one size fits all, such that one model is always best, right? But it usually depends on the kind of problem or you have, the kind of data that you have. As they said, sorry, for precise narrow domains, the symbolic NLP might be more efficient because you might be dealing with maybe a smaller set of data, text data, etc. And then when you have large corpora, then neural NLP might be best. Okay, so it's in as much as the neural NLP is an advancement, it is not always the best to use in every single situation. Okay, so at this point, I'm going to take a break. It's off. Okay, thank you, Augustina. Okay, let's take a break for the next 10 minutes. So we should be back by 12, um, 14. Please don't go far. You can just like hang around, but stay inside the meeting so that you know when I'm starting. Okay. If you have any question, you can leave it in the chat or you can speak. Okay. So as I was saying, for the sentiment analysis task in NLP, we are going to consider the symbolic, statistical, and the neural approach. So with the symbolic approach, given that you want to identify the sentiment of the text, you basically are looking out for any terms that connote a negative sentiment or any text that connotes a positive sentiment. And then for those words that don't connote necessarily positive or negative, you basically consider them as just neutral. Okay. And so with a symbolic approach, you are creating rules. So for example, you can decide to list all the words, all the English words you know that have a negative sentiment. Let's say bad, terrible, horrible, unhappy. Every negative word you know, you put everything there. And then you can just tell Python, okay, all these words mean negative or they have a negative sentiment. And then you can also put down all the positive words somewhere. Okay. So with the symbolic approach, what it will do is that given your text, it will look out for any word in your negative list that you have there. Okay. And if it finds negative words, then it will assign negative to your text. If it finds positive words, it will assign positive to your text. Of course, you can think further and say, okay, what if it has positive and negative? What will happen? For example, this is a great disaster. Let's say disaster is negative. Great is positive. So if you say this is a great disaster, then what would that sign? So based on these nuances, you can decide that, okay, let me make positive words represented by a positive number, negative words represented by a negative number. And then let's call the sentiment of the whole text the net sentiment. So if a word is not, if it's not positive or negative, assign it 0. If it's positive, positive 1. If it's negative, negative 1. And then at the end, just sum up the numbers. Okay, so if positive equals number of positive equals number of negative, then it's neutral 0. I mean, it makes sense, but in the real world, you cannot analyze the sentiment of a text like that. Why? Because of other nuances in the language, like sarcasm, irony, metaphors, things like that. All right. So the symbolic approach, I mean, it's something that I'm sure even if I give it to you as a Python, you can just write this if else conditions. You write it right now. Right? It's very, very simple. Not necessarily always simple, but it is very interpretable. You can easily understand what is happening where, right? But it has its limitations in that the natural language is so flexible and so nuanced. Okay, so I've really done a very long explanation, but let's just look at this example here. This movie is terrible. Okay, so how the symbolic approach will work is that it will create a rule. So terrible is a negative word. So it will check for any negations. So if it sees anything like not, none, and before, or anything connoting a negation of your negative word, then that means it should be positive. If it doesn't find any negation, then that word is negative. And when there's a negative word, it assigns it to a negative sentiment. So it would, from the symbolic approach, this text would easily be classified as negative, right? And it's be right. Now, the statistical approach, what will happen is that when it takes the text, it will extract features. Okay, things like word counts and then TF-IDF. And then it will train on some labeled data. Okay. And then it will eventually learn that the word terrible usually correlates with a negative sentiment. And then based on that, it would assign negative to the text. And then with the neural approach, which is really more like an advanced form of the statistical approach, it will convert the words to embeddings. It will process it through transformer layers, learn complex patterns automatically, and then it will come up with the results being negative. So you realize that for these two, for the statistical and the neural, we have um, a level of confidence attached to whatever the sentiment is. Don't worry about all these technical terms. We'll meet them soon enough and we'll understand what they mean. But this is just an example differentiating these three methods. Okay. There's much more information I have on this slide here about the distinctions between symbolic, statistical, and neural NLP. I believe I've spoken about most of them, but even aside that, I think that these are things that you'll be better off reading and being fine with, because there's some code I want us to run, so I'm going to skip this. But I've basically explained this to you already previously. Okay. So some common misconceptions to avoid. I already mentioned this earlier. In as much as the neural network approach is the most advanced one, it doesn't always it doesn't always replace the others. Okay. So each approach has its place. The rule-based systems are still used for legal parsing. Okay, so in the legal context or in the law context, and then statistical methods are still used for resource-constrained applications. Okay, so the thing about the neural network ones, you know that they need a whole lot of space and computation power to be able to be used. So in a situation where there's no luxury of storage and computations, statistical method and computational power, the statistical methods do well enough um, to still get the problem solved. Okay, and then older methods are obsolete. This is not necessarily true. So modern systems are often a combination of different approaches. Okay, so symbolic rules for preprocessing, statistical methods for evaluation, and then neural networks for call processing. Okay. And then the neural networks always perform better. That's also not necessarily always true. And it depends on the data availability, the domain complexity, and then the interpretability requirements. Sometimes simpler is better, right? Then we have you need to choose only one approach. That's not the case. Usually, the best approaches are actually a combination of several different approaches. right? So to basically make up for the shortcomings of the other approaches. If you kind of put them together in a way that makes up for the shortcomings of each, then you have a stronger system overall, right? Okay. So now let's go to Hugging Face. Hugging Face um is some kind of GitHub for machine, not just machine learning, but AI in general. So people share a lot of their models, they share courses, they share notebooks, um, documentations on different models and data sets they've come up with. Okay, useful for different fields, computer vision, um, multimodal learning, and also NLP. And so Hugging Face is a platform that we will really be using in this course to expose ourselves to some of the models and some of the things that are being done in NLP these days. Okay, so Hugging Face is an open source platform, okay, that provides tools, models, and data sets for machine learning with a focus on NLP and democratizing AI. Okay, so it's an open source platform and community. Okay, there are a lot of pre-trained models that you can use. There's a massive collection of data sets, and then there are easy to use tools and libraries. Okay, and this is their mission and impact. So one of the most commonly or common use cases of Hugging Face is for finding models to use in whatever um, problem or application that you want to build. Okay. And Hugging Face allows you to search for models with smart search filters. You can have looks at what the model actually does, how it works from the model cards. You can look at leaderboards to see which models are performing at the topmost performing. Okay. In recent times, you can look at trending section. You can also look at license filtering. So we're going to basically have a look at that ourselves right now. So I just did a little screenshot here of the um the models page, but let me actually just take you there. Can you see my, let me see. Yeah, you can. Okay. So this is when you go to Hugging, okay. So when you go to Google and you type Hugging Face, Hugging Face, okay. This is probably your first search result. And then that brings you here. I already have an account with them. You can get an account with them. And so it's automatically logged me in here, right? So you can go here to look at the models. Here you can see the data sets available. You can see things trending in the communities, collections, papers, etc. So let's come to models. When we come to models, oh, let me go here. When I come to models, these are all different types of models used for different things. Okay. So you can decide to search for models based on some specific tasks. So this is OpenAI's GPT OS. I don't know if you heard about it, but OpenAI has released their parameters. What it means is that you can create, you can write some Python code and basically incorporate ChatGPT's abilities in that code using these models. Okay. Of course, they are really large, so it will take up a lot of space. But it's possible now, before it wasn't. So these are just some models here. You can decide to filter them based on tasks. So when you look at text generation, the OpenAI models would be showing. Then we can look at image to image, image to text, text to audio, text to video. You can also filter the models based on parameters. Okay. So generally, the more the parameters, the better the model, generally. But then also, the more the parameters, the bigger it is. and if it's too big, and your computer doesn't have the ability to take it in, it will slow down your computer and crash your computer. So you need to be careful about that. And then some models are um, more compatible with some particular libraries. So you can also filter based on the libraries um, to choose the models that you want. And then if there's a particular model you have in mind, you can just search for the actual name here. I think there's this model, Alberta, let me check. Okay, there's the Albert. So these ones are mostly for text translation. The best models are okay. This is for film mask. Film mask is like fill in the blanks, kind of. So this model allow you to create a system that can fill in the blanks for any text that you give it. We'll be trying out some of these models soon, so you shouldn't worry about that. You can also filter the models based on specific tasks. We have multimodal here, we have computer vision, and then we have NLP. NLP is our focus for this course. So these are some of the tasks that you can filter the models based on, and based on libraries, based on languages, based on licenses, okay, etc. So that's just by the way. Another thing we can do is to look at the model's resume. So what exactly the model does and what it doesn't do. The training data about the model. So the model is like, let me give it to you in a very, very simplified format. Let's say you have a linear regression model. Okay. What characterizes or identifies the linear regression model is the your beta values. The beta values are the coefficients of the linear regression model. And so if someone has those your beta values, okay, let's say your model is something that takes in a person's age and predicts maybe their score in an exam. Let's say it takes in some information, age, maybe the school they went to, different information, and then it gives out their score in an exam. Then if you share your linear regression's beta values, the model's weights with anybody, then they can easily give the model, they can easily give their own values for age, school, blah blah blah, and get out um the predicted exam score, right? So when I say models here, I'm referring to the beta values in quotes for something that someone has trained. Okay, so some NLP model that someone has trained. So you can basically use their beta values or their weights to get whatever output that you want. So the model resume basically tells you what kind of model it is, what the model can do, whether it's text classification, summarization, text generation, etc. And then the training data. So let me go back to the linear regression model. If your linear regression has several different inputs, okay, then it means it will have several different weights or beta values. And the number of beta values it has is what we call the size of the model. So some models have as many as, let's see, let me go here. Where are we? This model has 120 billion weights, right? So you can just imagine the number of numbers. So the size is basically the number of weights or beta values that the model has, and then the sources, the potential biases, in the model. So the potential biases, as you know, depends on the kind of data the model was trained on. Okay, then the performance metrics, the F1 score, and the benchmarks. The benchmarks is like the comparison between the model's performance and other good models which do the same tasks, their performance. And then the intended use, the limitations and the biases, etc. So let's have a look. Okay, I did a screenshot of a model card here. This is for the GPT OS's 20 billion parameter model. But for any model that you see on Hugging Face, you have the ability to look at its model card and basically see the information about the model. So let's say, for example, okay, this is uh the same thing, but you can see that this one's uploaded by OpenAI, okay, and this one's uploaded by Onslaught, so it's a different person, even though the model seems to be the same. So this is the model card here, okay, and it basically has all this information about the model, how to use it. So if you wanted to use this model, you just have to come and copy this code here, blah, blah, and then run it in your Colab notebook or your Python notebook, and be able to get the results that that you want. Okay. Let's go on. Is there any questions so far? I hope I'm not moving too fast. I feel like I am, but then nobody said anything.
It's okay. I wanted to ask if we have to register to this Hugging Face for this class, for this course.
Yeah, I think you should register for Hugging Face. So yeah, you just go to Hugging Face, sign up. It's very straightforward, so you can just do that.
Okay.
Yeah. So now we're going to move to everybody's favorite part, the coding. So I have a notebook here. I'm going to share it with you now. There's also a practice notebook I'll share with you later. Right after this, um, I'll share with you. So let me just share this code, this link. If you're on your phone, you can open Collab on your phone. Okay. It's just that I don't know how fast it will run since it is calling a big model, but we can try and see. Um, okay. Let me make you a viewer. So it means that when you open the notebook, you need to make a copy in your drive so that you don't overwrite my own code. So I'm sharing the Collab notebook here. When I share the slides, you have access to the link, and then I'll also share the notebook itself for you. Okay. So this is basically where we'll be wrapping up. We're just going to go over this notebook. It's very surface level, just using some already existing models. Okay. And then you can, I mean, try out different things yourself later on. So to use Hugging Face's pipelines, okay, so pipelines are, I mean, I showed you a pipeline before, right? Is the, yeah. So it's the process basically that you go through to giving your inputs and then getting your outputs, the process that you go through. So over here, we are going to use a pipeline function. So the pipeline function, that's what I told you about, that we'll not look into it, we'll just look at the surface. But then this was going on behind the scenes. That's what comes to do here. So we'll look at the pipeline API. We'll start by, should I give you a moment to open the notebook? Or okay, let's just do it together. So we just run this to install the needed libraries. Okay. And then now we can consider this sentiment analysis example. So this is one of the NLP tasks that we can do. So we just import the pipeline function from transformers. And then we do sentiment pipeline equals pipeline sentiment analysis. So over here, this code is specifying the kind of NLP task you want to do. Okay. So if you went here and you okay, let me first run this. Okay. So when you do that and you do sorry, and you open the documentation for pipeline, you should see all the possible tasks that you can do. Like, so you can do audio classification, automatic speech recognition, depth estimation, document question answering. There are so many different tasks here that you can do. And what we are looking at is sentiment analysis. Where is it? Okay, so it's here, but it should also be somewhere here. Yeah. Okay. And that's classification. Okay. Either. Sure. So these are all the different things that you can do basically. So in case you wanted to try something else, you can always just come here to pipeline question mark, and then you see all the different things you can do. So over here, we are initializing a pipeline for sentiment analysis. Okay. And then you can define the text that you want to do here. So you just give, you can try to just give a single string, or if you want to do several, you can do a list. Or if you want to even go crazy, you can create a CSV file and then import that. Okay. And use it. So you define your list of text. Okay. And then you basically just do this. You just call the sentiment pipeline on your texts. Assign whatever result is to results. Okay. Then over here, what I'm doing is just printing out the output. Sorry. I've already run this before, so I don't want to run it again. But um, you see that you have here the text and then the label. So this is a positive statement with a confidence of 100%. Okay. So as I absolutely loved the new Spider-Man movie. And then the second one is the food was disappointing and overpriced. That's negative with a confidence of 100. Okay. So these ones are I guess they're relatively easy for the model to identify. Um of course, you can try out different statements and see what the model gets for them. But let's try something out ourselves. Let me copy this code here. Um and then I'll ask maybe three people to give me some text in the chat, or you can speak, and then I'll put them here, and then we'll check the sentiment of the text. Give something complex, something that might confuse the computer, and let's see the model. And let's see what happens. But it should be in English though. Don't add Pidgin or Jamaican. Okay, I'm waiting for some text from you. Okay, the movie you watched at the cinema was bittersweet. Okay. Any other? I mean, yeah, we need a few more. The appearance is given. I want to confuse the model completely. I really wonder what they'll say. Hmm. Okay, you're amazing. You feel the game. That's sarcasm. Okay, and then she's a confident thief. I absolutely loved. Eh, Karin, you. Wow. Okay, what is? Um, I absolutely loved the show, even though the ending was not dramatic and the main character was terrible. Okay, help improve the quality. Let's put it there. I think we have enough for this particular task. Any next text we'll probably use in the next task for the named entity recognition. Okay, so let's run this. Okay, so the appearance is given positive. Okay. You're amazing. You failed again. Okay, this is supposed to be negative, right? Because it's sarcasm, but they thought it was positive. She's a confident thief. Confident thief. Okay, let me add one more sentence because I feel like that one should have been neutral. So let me add maybe the car is black and see if they'll give neutral. Oh, okay. So only positive or negative. Okay. Um. All right. So they said that was positive, probably because of the confidence. And then the car is black. I wonder why black is negative. Let me try the car is white. Okay. Also negative. I absolutely love the show, though the ending wasn't dramatic. Yeah. Mm. Okay. Positive. They caught this one. And then help improve the quality, structure, and usability of data sets used in projects. Blah 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 blah. Okay, this is a positive. So this did fair. It didn't get everything though. Like it didn't get this one. It got the appearances given. It was bittersweet. Bittersweet. Well, they just picked bittersweet. Bittersweet is supposed to be negative. Either way. So I mean it did okay, but it didn't do all the way. Okay. So we can always try other stuff on our own. And when you get the notebook. And then I mean you can even build something with it. You can maybe pick some reviews and then get the sentiment of the reviews. Use it to identify whether a particular airline is doing well or not. Um okay, let's move on. So we have the named entity recognition. What's the time? 8 minutes more. Okay. So the named entity recognition identifies and classifies entities in text such as people, organizations, or locations. So we basically call the same pipeline, then we give it the NER argument. This this argument here is optional. Okay. And so we added that here. So let's give, for this sample, we have Apple was founded by Steve Jobs in Cupertino, California. Okay. And then we call the pipeline over the text. And then, okay. So let's see what they say. So as we are waiting, you can bring some examples for this one as well, for the named entity recognition. So it should be something that contains an organization, a person, a location. Not necessarily all of it, but just want to see whether the model will be effective in identifying these things. And you should try and use local things, like things that are specific to your country, to see whether the thing is biased towards you know, organizations and people known only in the places where the model was trained. So with this one, identified Apple as an organization, Steve Jobs as a person, Cupertino and California, it's identified as a location. Okay. Let me get about 2 examples. Time is already almost up. So let me get about 2 examples, then we can call it a day. You can speak or you can put in the chat. Okay, I'm waiting now for your examples. Okay, so the capital city of Ghana is Accra. Mm. Okay, one more. Okay. Okay. Okay, so for this one we have um we just improve the appearance of it. Okay, so for text one, we already have that. Then for text two, it identified Ghana as a location and Accra. Okay. For text three, it identified John Mensah as a person, Ghanaian as miscellaneous. Okay. And then Osu Castle as a location. He has identified Albert Einstein as a person, Nobel Prize in Physics as a miscellaneous. Okay. Then he has identified Arsenal as an organization and London as a location. That's great. So, which tasks could benefit from sentiment analysis, and where might named entity recognition be applied? What do you think? You can either speak up or you can write it in the chat. Which task do you think could benefit from sentiment analysis?
Monitoring customer feedback, like if they like a product or not, or if they are satisfied or not.
Mhm. How about the named entity recognition?
Okay, maybe in a hospital, um, they can identify which one is the patient's name, the location, and then the maybe the condition the patient is
Mhm.
facing and all that.
Yeah, that's true. Any other person? Thank you, Scholar. Any other? Any other task that can benefit from sentiment analysis?
In politics, if they want to know the feedback from the people,
Mm.
they might benefit from the sentiment analysis. To know if they are in their favor or not for a particular party.
Mm. Thank you. Anyone else aside Scholastic? I'm sure everybody has an idea. Just don't want to speak. You can type if you don't want to speak. You can type. Um, Politicians and political parties. Thank you, Scholar. Please don't answer it. Anyone else? Anyone else? It's already time. Anyone? Augustina, Brides, Priscilla, Ernestina. Funny.
Shakira, please. I went out. I just came back, so I'm still following.
Oh, okay. Because everybody is not listening right now. What? Karine, are you here? Priscilla, Sarah, Steve,
Hello.
Nde. Yes.
Please on the items and the company, right?
Any-
You said we should give example of some kind of recognition in terms of the product and then the company, like something like that.
Words can be applied in real life.
Okay, so I feel like in stocking, like for instance, company like the Melcom when they are um, stocking their items, so able to recognize like he made mention of the batch data to know that this product is made from this company, and I think that is some way we can apply that kind of recognition.
Right. I mean, what would be the inputs? But it's okay. Anyone else? Thank you, Ernestine. Anyone else? Doesn't mean that all 21 of you are not paying attention. Like nobody is listening, or you have no idea.
For NER, it can be used for information retrieval.
That's fine. So I'm going to share the notebook with you, and you can try your hands on them and read more around what we discussed today. So the next meeting, as I've mentioned, will be on Wednesday. But then the next meeting for today will be at 3. Okay. So we'll end it here for today. If you have any questions, you can reach out to me by email. Okay. All right. Have a nice afternoon.
Thank you.